Experiment B. Aim to determine the focal length of a convex lens by obtaining the image of a distant object. Apparatus and materials required: an optical bench, 2 uprights, a lens holder, a convex lens, screen, pencil, and scale. Theory: the focal length f of a convex lens is related to its object distance u and the image distance v by the lens formula 1 by v minus 1 by u is equal to 1 by f. Here f is the focal length, u is the distance of the object, and v is the distance of the image from the optical center of the lens. According to the new Cartesian sign conventions, u is negative while v and f are positive. If the image formed is real, when the object lies at infinity, distant object, the image is formed at the principal focus. The distance between the screen and the lens gives the focal length of the convex lens. Procedure: place an optical bench on a table near a window. Place both the uprights on the optical bench. Fix a lens holder along with a convex lens on one upright. Fix a screen on the other upright. Turn the optical bench so that the convex lens faces a distant object like a pole, tree, etc. Obtain the sharp image of the distant object on the screen by moving it towards or away from the lens. Here is the measurement of focal length of a convex lens. When the sharp image is obtained, measure the distance between the lens and the screen. It is the rough focal length of the convex lens. Repeat the above experiment 2 more times by obtaining the images of 2 different distant objects. Observations and calculations. Now, record all the observations in the following table and calculate the values. Result: focal length f is equal to f1 plus f2 plus f3 divided by 3, which comes out to be how many centimeters? Precautions: the principal axis of convex lens should be horizontal, that is, the lens should be placed vertically. The base of the stands of convex lens and screen should be parallel to the measuring scale. There should be no obstacle in the path of rays of light from the distant object incident on the convex lens. Adjust the position of convex lens such that the light rays coming from distant object falls on the lens without any obstruction. Fifth, in order to obtain a sharp and clear image of the distant object on the screen or wall, it must be ensured that the distant object is well illuminated. This would allow a significant amount of light to fall on the lens, which is required to produce a well illuminated and distinct image. The image of the sun formed by the lens should be focused only on the screen. The image of sun should never be seen directly with the naked eye. Sunlight should never be focused with a convex lens or any part of the body, paper, or any inflammable materials, as it can be risky to do so. In certain situations, the parallel rays of light originating from a distant object and incident on a convex lens may not be parallel to its principal axis. The image in such cases might be formed slightly away from the principal axis of the lens.